I was not planning to make another episode about the 1973 Plymouth Duster, but something happened. A week or two after the last episode, I had been driving the car back to work for several days and all was going well. So one day I decided to go out on a local highway and do a speed run, top end this thing and see how fast it would go before I made any modifications to it. And here's where the fun begins. I got all the way up to 87 miles an hour, and I happened to look over and see the ammeter is at full discharge. That's bad. And so engine starts running rough. I pull over on the side of the road. I look and see what's happening. You know, nothing's leaking. Nothing seems to be broken. I let the car sit for a minute or two while I'm looking all over everything. And I get back in the car, start it up, and I drive about 20 more miles, stopping again along the way and restarting it. Made it back home, no problem. The next morning, it won't start. It will just, crank and crank, but it will not fire. So I come out here and I start looking around and I see what happens. Now right now I have the alternator out for other reasons, but I had a short circuit in these wires going to the alternator. You may not be able to see this too well on the camera. The big wire that burned up, yeah, I already took it out, so it's not here, but from up here back to about there, it was bare wire. Insulation burned off the whole way. And here, maybe you can see, there are a few other wires that are melted together and all damaged. So this 52-year-old PVC insulation that is really stiff, and I'm sure it's cracked all over the place, it said enough. So I said, okay, I'm ordering a whole new engine wiring harness. But to solve the first problem, why won't the car start? These two wires are temporary wires I have in, running to this 2-wire plug on the distributor. It goes from here over to the ignition box there. The distributor gives it a signal, tells the coil when to fire. So I ran these I tested the original wires with this wire unplugged. And I tested from over there. It should have been just 2 wires going parallel to each other. No contact. It should have been an open circuit. It wasn't. It was showing 8 ohms of resistance. So these 2 wires in the original wiring harness, they're melted together and touching somewhere. So I made these 2 little temporary wires to bypass the entire circuit to get a signal from the distributor to the ignition box over there. And I did that, pumped the gas once, it cranked right up and ran nice and smooth. So okay, this wiring is shot. This 52-year-old wiring has had it, and I'm not going to mess around with it anymore. So I started looking around. I made a post on a car forum for these kind of cars, and I started looking into the wiring a little more and more. And I noticed this back here. You see all these purple wires here? They're not supposed to be here. There's supposed to be a plastic connector plug that plugs in that part of the wiring to this part of the wiring. Someone decided, the previous electrical genius who had this car, he took out the connector and put all these purple wires in to bypass the entire plug. So all this old wiring is coming out. I have a whole new wiring harness. It's all going to be replaced. We have a heavy-duty aftermarket OEM wire for the alternator. That'll stay. Everything else is getting changed. And there's one little kink in the plan, because the wiring harness is available for a V8 engine, not for a slant 6. And the only problem is, on a V8 engine, the coil and distributor are right about here. And my coil and distributor are around the side of the engine and way up over here. So I have to extend a few wires. The alternator wires are long enough. The engine temperature sensor wire up here, I may have to extend it. The wire going down to the oil pressure sending unit switch, I'll have to extend that one. The 2 for the distributor, I will have to extend. So, not a big deal. It doesn't matter doing it right, doing it carefully. And it all plugs in right over here. These connectors down here, 2 of them will come out. And as part of this wiring harness, there's more. It comes up the side. The original wire from the alternator would go to the starter relay. I'm not using it. I'm using the bigger aftermarket one that already has a fusible link in it. Wires come up here. They go to the headlights, to the front light turn signal, to the side marker light, and to the L31 code fender mounted turn signals if this car had them. Then the wires come across here and they plug into this side to the marker light turn signal, to the headlight, to the L31 code fender mounted turn signal, and the side marker light if it had it. So that's the one wiring harness. I'm taking out of here and putting a new one in after I extend the wires, and that should be better. While I was testing here, I took out the new ignition control box and I put an old one in. That didn't help. While I was running the car like this by having the key on, the ballast resistor was getting hot, and it shouldn't have gotten hot that fast. So I shut that off. So it worked long enough to make the engine run, make sure I know, okay, there's no other problems. Now change all this old wiring, because who knows what else is shorted that shouldn't be shorted, or grounding out, and handle the problem. Here is what the new wiring harness will look like, more or less laid out how it will be in the car. I got it from year one. And also, here's a tip for you. When I ordered this thing from year one, before I finalized the order and hit send, I went online to Google, searched for year one discount codes. And after 3 or 4 tries, I found a discount code that saved me 20%. Yeah, that covered the cost of the sales tax and shipping. So, a little bonus there for me. But anyhow, the wires plug into the firewall there. They come over here. I've got my wires for the electric choke, the distributor, the oil pressure sender, and 2 wires to the coil. These will have to be extended. Then up here I have the wires to the alternator. They're okay. Then I have the wire to the temperature sensor, which I will probably have to extend. I don't think that would be long enough. And coming around this side of the car, we have the wires to the voltage regulator and the wires to the ignition control box. Wire to the starter relay, which I won't be using because I have other wires in for the ammeter, for the alternator. Wire to the windshield wiper electric washer pump, which this car does not have. And a wire to the brake switch for emergency brake problems. And up here we have wires to the horn, wires to the front light, wires to the headlight, wires to the L31 code fender mounted turn signals, wires to the side marker light, and over here the same things: front light, headlight, side light, turn signal light. So the old wiring that looks like that and is in the car like that will come out, and this new wiring harness will go in. I just have to put the wiring harness in the car in place and get an idea of how far do I have to extend these wires. And maybe this one. This plug right here is what was taken out of the wires that are in there now. Some genius, he decided to bypass this whole connector and run the wires straight through. I tried pulling this connector apart and it's pretty stiff, so I didn't try to force it. No need to mess with it. But that's my project right now. And then getting the wire to extend these with. The company wanted to charge me $20 per 25-foot spool of each color wire. And their website brags about how their wire is so great, it's the same kind of insulation that's in new cars. Really? Okay, you shouldn't have told me that. So I went to a local junkyard and I found a 22 Dodge Charger that was all taken apart. And I took a lot of wiring out of the driver's door assembly for all the power windows and everything. And I cut it apart and they got me a whole bunch of extra wire to use. I'll show you that. This is all my extra junkyard wire. New wiring from a car that was a 2022 model Charger. Different colors, different sizes, different lengths. So I will get what I need from this new wire with the new style insulation on it, not old PVC stuff, and I will make my wiring extensions from that. Now I have the new wiring harness set in place pretty much. It's going to follow right along there. It'll come around the corner, and the new wires will go to where they have to go. And the alternator wire is plenty long enough, no problem. But everything else needs extended. This temp sensor wire will not reach to there. These other wires to the electric choke, oil pressure sender, distributor, and coil are all short. And I went to measure them, and I can't find my ruler anywhere. I have a tape measure in the car, and I don't see where it is. So I got this roll of paper towels out of the car. The label on the package says it's 11-inch long rolls of paper towel. So I'll use this for a tape measure. We'll pretend it's 11 inches here, and if we go right there to there, 11 is plenty long enough. And for all these wires here, 11 will make it. And if we're going down to the oil sender, a foot, I'm sure will be plenty long enough for that. So I will extend all these wires by a foot, maybe a little bit more, just to be on the safe side, because I only want to do this once. It's okay for it to be a little bit too long, just don't let them be a little bit too short. So that should work. So that's today's project. Go home, cut into this brand new wiring harness, and make wires longer, because they don't make a version of this for a slant 6. Not enough sales, not enough corporate profit. They give you the V8 unit and say, here, adapt it, make it work, it's on you. And all these new wires over here coming up to the front of the car, that's not a big deal. Everything reaches, everything is fine. It reaches the voltage regulator and the control box for the ignition, no problem. This is all good. It's only over here I have to make changes. And now I am doing the extending work. Here is the temperature sender wire. I've already extended it from here to here. Give it about a 12-inch extension on it. And it's going pretty well. Had some complications. I'm using this really old, cheap soldering iron that doesn't do very well, but it gets it hot enough to melt the solder. Got some 6040 tin lead solder, heat shrink tubing, rosin flux pen, wet paper towel, electrical tape, razor blade. I originally started with the whole idea of the crimp connectors, and I was even using my vice grips set really tight to really, crush those things down, and the wires were pulling out very easily, much less having a good electrical connection. So I said, okay, forget it, we're soldering each and every wire. So these wires need to be extended. I have one down and 1, 2, 3, 4, 5, 6 to go. Now, this is not the ideal soldering setup by far. Way back in the 90s and early 2000s, before I was doing IT work, I did electronics technician work. I had access to good professional grade soldering irons. You could change the tips on them, set the heat wherever you wanted it, and especially when we didn't have lead-free solder to use. That lead-free solder, that is such a pain to get it to flow right and do what you want. I'm soldering inside of IC chip sockets and very small connections. And I was really good at it too. Job didn't pay very well. At the time, like 12 bucks an hour. At the time, it was okay, but even back then I knew I should be doing a lot better. I just wasn't getting it into my head yet. Hey, go do IT work. Now, the thing about this is you gotta let the heat flow through, and don't just touch the solder to the iron tip. Put the iron on one side of the wire and keep the solder on the other side and allow the heat to draw the solder through. Because you don't want it to be soldered right on the surface. It needs to be melted and connected all on the inside here. And there you go. And that's one more solder joint all set. Let's have a wet paper towel here to clean the tip of the iron off. Get the built up flux and solder off the iron tip. And this time I put the heat shrink tubing on the wire before I soldered it. I already did one wrong. I had to cut it, put it down the side in the heat shrink and kind of melt it over. And now I'll use a match to heat the heat shrink tubing to melt it down and shrink it down. In a perfect world I'd have a heat gun for this, or at least a hair dryer, but I don't have one here, so I'll use this. And this is getting the job done. I'm sure not going to spend the money on a heat gun just for this one little job. So we'll do it the Loudmouth Tim way. And what's that? Any regular viewer of my show should know by now. Almost as good and a whole lot cheaper. That's the Loudmouth Tim way. And there we go. That heat shrink tubing is heat shrinked. Here's one last little piece of video. This is the actual failure of what went wrong. This is the rotor of the alternator. I looked at the alternator shop and he showed me what happened. You have this field wire coming in to where the brushes are, and this is insulated from touching anything else. And the field wire over here is also running between the fan blades, and it's insulated from touching anything. What happened was this whole fan assembly broke loose and was able to rotate a little bit. Not much, only about a ½ an inch, but watch right here. This is where it was supposed to be, and this is where it ended up. Touching to the fan, touching to a ground on both of them. That's not good. That's not what is supposed to happen. And that shorted out a whole bunch of wire and caused all the problems. So the whole rotor was replaced with a different one, then the alternator was rebuilt, and now it's all good again. And the guy who rebuilt it said he's never seen one fail like this before. Well, hey, lucky me. I'm the first one to ever have a fan rotor break loose and spin and touch and ground out the whole alternator, which was running at high speed because I was doing a speed run at that exact moment. So it had a lot of power getting pushed the wrong way. Well, it's time to start taking out the old wiring harness, starting over here, disconnecting everything. And I did find the original wire. This is the first wire that burned up. All that got melted, all the insulation gone off that wire. So it was shorted out to something and making a lot of heat. I'm back here pulling out the wires, and look what I found back here, a whole bunch more melted wire. I guess it grounded out on the engine valve cover. That's a good way to make the ammeter go to full discharge. But that should not be all burned and melted like that. And over here, right behind the brake booster, I found some more wire that looks kind of bare and shorted out and not the way it should be. Well, that's 3 places so far we had a good short circuit. Wow. When this thing went, it went. I got a lot of the way through taking out the remaining old wire and starting to put the new wiring harness in, and I realized I hadn't taken any pictures. So here we are. The new one is going in. It's looking good so far. Having to very carefully route it in, over, under, through, around, and between everything else. And we're up this far here. Now the final part is this section that goes to the headlights and turn signals and marker lights. So far it's doing really well. And everything is fixed now. The new wiring is all in place. Put the starter and alternator back in. I took it out for about a 60-mile ride this morning. I changed that idler pulley on the AC belt too because its bearing was starting to squeak. But everything's back in shape. It's good again. Now I have to find something else to work on. That won't be hard. One job complete, many more to go.